Data Lunch and Learn. My name's Treg Gilstorf. I'm the COO here. Really excited about what Dev's going to share on React today. Feel free to get up anytime, grab food, refill your drink, whatever you need to do there. If you have questions, just put your hand up. I'll kind of watch the room and come ask and let you ask your question. Dev will be on virtually. The virtual folks will also throw things in the chat, and they'll be asking questions as well during the presentation. So with that, I'll turn it over to Dev.
How's it going? How's it going? Thank you very much for having me here. Is my audio coming through fine?
Yes.
All right, cool. Thank you very much. I really wish I could be there in person, but today I'm joining virtually. I'll hopefully make it there some other day. But thank you very much for coming to this talk. It's called Streams, Not Waterfalls. I'm mostly going to talk about, or I'm going to talk a lot about page load, data fetching, core web vitals, but also more importantly, how that affects us, our developer experience, our authoring experience. I'm also, if you don't know what streams and waterfalls mean, I'm going to explain those terms and what those mean in the context of web development soon. I'm Dev, and I'm a dev. Yes, that is my actual name as well. That's not a shorthand. I work here as a software engineer. I've been with Smart Data for about 5 or 6 months now. These are some of the projects that I've worked on in the past. These have been like full stack applications that were developed both together that I've had a significant contribution to, and a lot of my own full stack experience I derive from my time working on these projects. And if you like my talk today, I make YouTube videos sometimes. You might like my YouTube channel as well. And of course, I kind of live on Twitter, so I mostly shitpost there, but also I post sometimes I post interesting things as well. Okay, so I want to start by talking about single page apps. I'm sure a lot of us here use React, Angular, something like some sort of a front end framework that helps us build better single page apps. And I really love building single page apps. I feel like these JavaScript frameworks give me a really high ceiling for user experiences that I've never had before, or I can't really get in other ecosystems. The ability to control everything on the client side, immediately render something, talk to the server as we need it, show optimistic updates, things like that. It's really powerful, and it enables building really nice experiences for users. And that's kind of why I'm still with JavaScript, even though it's kind of a weird language to write in sometimes. But it allows me to build really nice apps for users. But what does that experience look like for a user? Single page apps are not like always the greatest thing. Let's see what an initial load or a page load looks like for a typical single page app. So we have a browser that makes a request to the server, gets an HTML response, and then it spends a lot of time downloading some piece of JavaScript. And give me 1 second. I think my speaker just disconnected. I need to reconnect that just in case there is any questions. Right. So the answer there is, let's just split those bundles. Before this, we had a huge chunk of JavaScript that is basically our entire application that we had to download in one go, and then our application starts, or our single page app starts running. But clearly this is not a great approach. So we discovered, or we built things like code splitting and dynamic lazy loading into our bundlers so that we can do something like this, where once we have the first HTML response, we only have to load a little bit of JavaScript. And this first chunk of JavaScript is going to have some sort of a route manifest, or basically an object that tells us where other bundles are and when we need to load them. And then we fetch those individual bundles that we need to render the current page. So this is also called a route-based code splitting, where each route of our application is going to have a different file, a different entry point, and based on which route the user is on, we're going to lazily load that in that code and then show it to the user. Now, this solved our initial load problem where we had to load a huge chunk of JavaScript at the beginning. And we can do this because we have this thing called Ajax, which is the ability to make requests to the server using JavaScript. Ajax is really the kind of superpower that enabled us to build single page apps or these highly dynamic experiences. I'm too young for this, but some of you might have been around when Gmail, apps like Gmail or Google Maps first launched and used this capability to build really nice interfaces. And that's kind of what the next decade or so of web tried to model itself after. But Ajax could be a foot gun as well. And let's talk about how. So I want to give you all a small task, homework, challenge, whatever you want to call it. Next time you're using throughout your daily routine or weekly routine, whatever it is, just take a note of the different apps that you're using throughout the day and how much time you spend just looking at loading spinners. So you might be using Gmail, you might be using Microsoft Teams, Outlook, Notion, anything like that, any apps that you're using on the daily. Just take a mental note of how much time you spend just looking at loading spinners. And then try to do that with the app that you're building and see if what you're building is better than the industry average or not better than it. Cool. So this is why I think Ajax could be, or not taking care when we are talking asynchronously to the server could be a problem. Here we see that once we have fetched those JavaScript bundles, we also need the data from the server, but we can only start fetching the data once we have the code already. If we don't have this code, we don't know what data to fetch. So we run into this problem of cascading waterfalls, where we first load the initial JavaScript bundle, then we load the route bundle, then we load some data, and maybe after we are done fetching this data, we realize that we need something else. So we go back to the server again. And this is what I mean by a waterfall, or specifically a client-server waterfall, which can be made much, much worse if your client is, or if the user is sitting somewhere far away from your data centers, or if they're on slow, unreliable networks. And this is why we have those loading spinner problems. But why did we run into this problem in the first place? It's because we like, or at least this is what I think, it's because we like the composability. Composability is a really nice thing that allows our code bases, our apps to scale with complexity really nicely, because everything is kind of encapsulated into small composable pieces that can be just put together. That you can use these pieces without having knowledge of the internals, or when you're building one of these pieces, you can just build them in isolation with the rest of the system. And this is the reason that React got popular, that component-based solutions got popular so much. And in this specific example, this is what composition looks like. It's the co-location of the data and the UI. So whenever we show some UI in a component, we want to co-locate the piece of data that this UI needs. This is just an example of what this might look like. Let's say that we have, this is a React component. Let's say we have some hook called useGreedy, and this fetch my data function goes to the server and gets some data that we are going to show in the same component. Now, there are some really nice things about this way of writing components. This is very flexible. We can fetch data from wherever we need inside whatever component and do whatever we want with it. This is composable, like I mentioned. We can use this component wherever we want without knowing about the internals of it. This is scalable. We can build 1,000 components like these in our apps, and they don't have to interact much with each other. We get locality of thinking with this, because when I'm working on this component, I don't need to know how my routers are set up, or if I have some other state management going on. I just need to build everything inside this component, and that's it. This is also obviously very type safe because we don't need to do any additional work to tell TypeScript what type this is going to be, because we are getting that directly from this function. But like many things, composability could be a foot gun, and it's because of that waterfall problem. If the data fetching code is located inside the component, we first have to wait to fetch this code, this component, and then we have to wait to execute this component before we can actually start fetching the data. And if we have components inside components inside components, we can get into very complex trees. And you can imagine how worse this problem can get. Because if a component that's nested inside 4 or 5 layers is fetching some data, you might have components above it fetch first and therefore block anything else that happens on that page. So let me show a quick demo of how this works. So I have the same demo here in 5 different or 4 different kind of approaches. I'm going to start with this one. I hope everyone can see it. It's just a basic like a dummy e-commerce thing. I'm going to hit refresh here, and you're going to see what's happening. The first time the page loads, we don't have anything, obviously. But then we show the loading skeletons for these two while the data is fetching. And then once we have the trending, once we have this, we start fetching this data. And then we get this at a certain amount of time. Let's slow down the network and see how that impacts. So now we are on fast 4G. Let's go on slow 4G. And let's refresh and see what it looks like now. Look at that. It's stuck on the skeletons for a while, and then it starts loading, and then eventually, one by one, the data comes in. How many apps that we use on the daily routine look kind of like this? Probably a lot of them. Let's see what the code looks like, though. So again, I have all the 4 different demos here. I'm going to go to the normal one. This is built using Remix. Remix has SPA mode, which means it doesn't do any server-side rendering. So this is what it looks like. We have our index page here where we are rendering featured product, which is this entire section. And we have the for you products, which is this section. Let's go into the featured product. So here we see that we have the use query, which comes from React query or TimeStack query. We get our featured product data. If that doesn't exist, we show the skeleton. And if it does, we show this entire piece of UI, and then we show the trending products, which are these 3 here. And if we go into trending products, you'll see the same thing. We have a use query call to fetch some data from our API, and then we show these 3 products here. The APIs they're not really APIs. They're just dummy APIs returning dummy data. That's not important. That's not really relevant to this talk. But what's important here is each component is fetching the data that it needs on its own. It doesn't need any outside help to do that, which means we can render this wherever we want, and it'll work exactly as we expect it to. We can see the same thing in the for you products. We have a query to get the for you data, and then we just render that. Now, there's a lot of benefits with these approaches, but this one by one, the looking at loading spinners for a long amount of time, for a long period of time, this is definitely not one of those benefits. Okay. Quick side note before we move on. There's a whole category of applications, or I should say a movement of an approach to building web apps, which is called offline first or local first. The idea is that user data is stored directly on the user device, which in this case would be a browser storage like local storage or IndexedDB or something like that. And instead of going back to the server, you can just read from that local copy. So almost every single navigation interaction will be instant because all the data is stored locally. And then you have a sync engine like Replicache that talks to the server and always keeps your local state in sync. It's a very interesting approach and could be used for a lot of applications to make them really fast, but that's not the purpose of this talk. Okay, so if the composable approach is hurting the performance, I guess we can hoist our data. Hoisting basically means pulling the data fetching out of our components and putting them somewhere up above where we can optimize them better. So in this example, we're using the example of something like React Router or Remix. This is our page component, our route, and we have an additional function next to it called loader. And the loader function is where we are going to fetch our data. And inside our page, we either get this data in through props or through a context hook, and then we render that. So now we have separated out the data and the rendering into these two different things, and they're at the route level. So anytime you want to add something, you need to go to this loader, you need to add the function here to fetch the data, and then you need to go to your component, access it from this using this hook, and then show it in your UI. So there are some problems with this. This is a brittle approach. This is more difficult to change because every time you have to change, you now have two or three different points of changing. This is also disjointed. So if you have a bunch of different components in your page, some component might be down the tree that needs some weird data, and then you have to go all the way back up to your loader to make sure you fetch it. So every time you have to add something new, you also might need to check if, hey, if I'm adding a new component, the data that I need for this new component, am I already fetching it, or do I need to fetch it, or do I need to add an additional function for it in my loader? If I'm already fetching it, does it have all the fields that I need? If it doesn't, do I update that query to include the new fields, or do I just make a new one? It gets worse if you want to remove something. You can remove any component, but what about the data that you were fetching for that component? Can you just freely remove it, or do you might have to go and check through your entire route if some other component is using that data, or if it's using some fields of that data. So it's very error prone in that way. It's hard to refactor or move things around when everything has to go through the single point, which is your route loader. That said, it can kind of remove all the waterfall problems that we were having with our composable approach. Because as soon as we have our initial JavaScript bundle, which has all the information about our routes, we can start fetching the data for any route that we are on immediately and in parallel. We don't even have to wait for, because we don't have multiple loaders, we can just execute them all in parallel. Sorry, I have to give my cat treats or if it'll jump on my keyboard. So let's see what this looks like. Oops. I have another demo here, client hosted, and let's refresh and see what this looks like. So we have a loading, but then we see all the components at the same time. And the reason this works like this, let's go to our client hosted demo. I'll go to my index route. And what we're doing here, we have a loader function defined next to our component. And we're fetching all the data at once in this loader here, and we're just returning it from the loader. So once we go into our component, we can use this use loader data hook, and we get all the data. We can just pass it down to our components as they need it. And this component is only going to be rendered once the data fetching is complete. So you can already see the effects here. I'm going to open this up here and refresh them at the same time. So you can notice the difference. I'm going to zoom in a bit here as well. Refresh. Okay. So you see that we got the content of this whole page before we got the content of this whole page. But because here we were waiting for all the data fetching to finish, here we can see the loading spinners earlier. Now, we have some ways to show the skeletons in this version as well. I haven't implemented that yet. But the point is, you can see that the final load or the complete load or rendering of this page was earlier in the hoisted example because we fetch all the data together instead of doing it one after the other. And this also solves the problem of lazy loading. So if I go to a different page, you can see that I go to the page, we wait for the code, and then we wait for the data. Here, here again, the work is happening more in background, but we are going to start fetching that data before we even have the code. Okay. So another quick side note here, GraphQL, which is a fantastic piece of technology that I think not all of us should be using. But if you are using GraphQL, there's an amazing tool called Relay, which was built by the people at Meta. Relay is a GraphQL client that essentially eliminates both of these, the composition and the waterfall problems. And my cat is here. Here. So what Relay does is it allows you to put queries in your components and not have to hoist them up. But what Relay will do at a compile step is it will go through your components and statically extract all the queries and hoist them up to the route level automatically. So you don't have to do hoisting like this on your own. You can just write your GraphQL fragments inside your components, and they will be hoisted up for you. Now, if you're not using GraphQL, I'm not saying that this is a reason you should move to GraphQL, but if you already have GraphQL or you're already considering it, just know that this entire category of problems that I'm talking about, they can be eliminated using Relay. But for the rest of us muggles, maybe server rendering can help. Usually, I know there's been a lot of talk recently in web dev about let's render the UI on the server and server HTML pages faster. Mostly probably because of SEO, but it actually does help because when we are server rendering, the advantage is not just that we are sending the entire HTML at the beginning, but it's also that we are fetching our data directly on the server. This has a really interesting advantage that our server is much closer to our databases than our client is to a server, which means if even if we have some waterfalls, even if we fetch some data and then we go back to the database after the first one, this is still going to be much shorter than if the same thing happened from the client, because the client server networks can be an order of magnitude worse, especially if your clients, your users are in unreliable or slow networks. So from the server, you can fetch your data almost instantly and then just send the final rendered HTML to the client. And after you've done that, the client can start loading the JavaScript that it needs to make that page interactive. Let's see what this looks like. So I'm going to go to the server hosted page. And here you're going to see that it actually looks very similar. We still have a loader function. Instead of client loader, it's now loader. And inside our page, we still use a hook to access and to pull that data out of our loaders. But the difference you might see is that here we're using server API. In the other version, if I go to client hosted, we're using client API. Now, the only difference here is that I have an artificial delay in both of these. And for server API, I have a much smaller delay to kind of emulate the idea that from the server to database, you can fetch data much more quickly compared to if you went from the client to the server. So here, I'm going to run this again. Or let's look at the client hosted and the server hosted together and see how these compare. So I'm going to refresh both at the same time. And you see with the server hosted, we just have it. Did you see how long it took to load this here? I'm going to refresh this. And here, you see loading is already finished. It's because a server is, as soon as the server receives a request for this page, it immediately starts fetching the data. And it does that in parallel. So in my earlier example, or in my slides, there was a slide waterfall. But here in this demo, we're using await promise all and then getting all the data together. So not only is it fetching on the data, but it's also hosted on this server, which means it's going to be much faster. And it also has the advantage that it's going to render the entire page on the server and then show it to us immediately. So we don't even need to wait to load the code or load the React components that we need to render this page. All right. So let's compare what we have so far. We have our classic SPA with just code splitting, with not a great initial load time, not a great navigation time, because again, you always have those waterfalls, those cascading waterfalls, those loading spinners that show up all the time. But it's a really composable approach because you can co-locate your queries within your components. But then we go to hoisting, which really improves our initial load and navigation performance because all the data fetching can happen in parallel. It can happen before loading our code, but it makes our code a lot less composable because now we have route loaders to deal with. And because of all those difficulties I brought up in changing the code or evolving it. We can add server-side rendering and keep our composability, improve our initial loads because we are rendering on the server. But after the initial load, everything is still the same. So navigation is still as bad as a regular SPA. However, if we combine both approaches, hoisting and SSR, which is essentially what I was showing you with Remix, we can get almost the best of both worlds in terms of performance. We get great initial load because we are rendering on the server, and we get great navigations as well because everything is hoisted up. So every time you go from one page to another, all the data fetching will happen in parallel immediately, and then the page will be rendered as the data gets available. But once again, because we added hoisting back in the mix, our components are not as composable anymore. So maybe streaming is a solution. So before I go too deep into it, I'm going to just give a quick intro on what streaming is. Streaming is kind of a capability with HTTP that has existed for about 2 decades now, if not more. The basic idea is when you send in an HTTP response to some client, it could a browser or anything else, it could be, you can keep the response open, send an initial chunk of response, and then keep adding more data to that response over time. So you don't have to send your entire response at once. But the problem with this is that it's a sequential stream, which means you send some data, some text data, and the next time you send some data, it gets appended below it, and then below it. So you have to stream stuff in a specific text sequence. This is the reason this hasn't been very useful is because we build UIs hierarchically. We don't build UIs that are completely in a sequence. We have a tree. So we don't want things that are taking more time to be at the bottom. We want them to be down like inside a nested tree, which is not really easy to do with normal streaming. That said, if let's say hypothetically we had we could use streaming in whatever way, we could do something like this, where the server can start fetching some data, but then it can immediately respond with HTML as it's fetching more data in the background. So you can see that the HTML load has shifted to the left a lot more. Before earlier it was here at the yellow, but now the client can see some content and start loading the JavaScript while the server is still doing more work. And once it's done, it's going to send that data back in the same response stream. And then our JavaScript can continue executing and making that page interactive. We can even take this orange line and pull it all the way back here, which basically means the server can send back an initial HTML response, basically as soon as it receives the request, without waiting on any data at all. And then it can fetch all that data in the background and stream it down as it's available. So streaming unlocks this really nice performance benefit because you can very efficiently parallelize work between the server and the client. Now, I did say that streaming hasn't been useful, but it actually has been useful for about a decade now, especially in multi-page app land. So multi-page apps, or apps that are completely rendered on the server, And then like every time you go to a different page, it causes a full page reload. You go back to the server, and the server gives you a fresh HTML page. MPAs have had the ability to stream for a while. Marco is a framework that was created by eBay that's used on ebay.com. And the kind of big innovation for Marco is its ability to stream HTML, also called out of order streaming. Here in a classical MPA, we can I've given initial load and navigation a 3, which is kind of the average, and it's also the same score as our single page app with SSR. Because what's basically happening here is the server gets a request, it has to do a bunch of work, it has to maybe talk to a database multiple times, and then it sends back an HTML response. This is really nice for MPAs and really composable as well. But once we add streaming into the mix, we can really, really improve those performance metrics, because we don't have to wait for all the work that the server is doing Maybe it's talking to database, or it's running complicated queries, search engines, or AI responses, whatever it could be, slow API calls. But those that slow work doesn't block us from sending back responses to the client. So you can see that MPA with streaming is effectively an absolute maxima for performance on the web. It obviously isn't very interactive because you don't have a lot of client-side JavaScript. And as soon as you try to make some elements of your page interactive using islands by, let's say, like adding some jQuery or embedding like a mini React or Vue app inside your Rails app, suddenly you really hurt your composability as well, because now you have a server app and a client app, or a server app and multiple client apps that you now have to deal with instead of just building one app. But again, it has really nice performance, and it has some interactivity that you can get. But we are not really talking about MPAs today, are we? We're talking about SPAs. How can SPAs improve with streaming? Well, we can use streaming to kind of squeeze out the last bits of performance for our initial loads and for our navigation, and really improve those things as well. Let's see what that looks like. So I'm going to go to the same server hosted demo that I showed earlier, and I have the code for it. So what's happening here is if I hit refresh again, oh, that's client hosted, sorry. Here, so if we hit refresh, we're waiting for the whole page to show up. Let's make this slow 4G, and let's see what it looks like now. So we're waiting, and then the whole page shows up at once. If I remove this await promise all from here, now this is already set up to do streaming. We basically use this defer function to directly return promises instead of awaiting that promise and returning data. If I refresh it now, you'll see. Okay, let's make this no throttling actually. Okay, so it's kind of hard to notice streaming with network throttling, and the reason is that because when I throttle the network, the time it takes for the initial response to come back to my client, and that time the server has already finished loading all the data. But if I refresh here, you see that we now have those loading skeletons show up for a little bit. Let me make this a little clear by exaggerating the API delay, and now you'll see here. So we see the loading skeletons, but then we see all the data come at the same time. This time we are not making those calls from the client. As soon as the server receives the request for this page, it has already started fetching. It has already started fetching all this data on the server through this loader. But then it sends us back this component rendered with the loading skeletons. You can see it here. And once we have the for you data, we show this component. Once we have the feature product data, we show this component. And then we show the whole thing. So instead of the client waiting on, or the client making those requests and waiting on them, the client has just got the promises that represent these data, and we can use suspense to show fallbacks here. If you're not familiar too much with suspense, don't worry about it. It's kind of a way to just show loading skeletons if something is or if something inside is loading or waiting on some asynchronous task. So this is we can stream our data in Remix. Other frameworks have a similar way to stream, where you can just give it a promise instead of awaiting it, and that data will be streamed down to the client. So this is the kind of the evolution of single page apps and multi-page apps using streaming, and basically the pinnacle of what both of these architectures can do. I'm going to explain hydration really quickly. So when we render something on the server, especially using JavaScript, we can show the HTML content or that the rendered result of that immediately, but that won't be interactive on the client side because we only rendered it on the server. We haven't attached any event handlers to it. We don't have state on the client yet. So after some HTML content is shown, we still need to download and run some code that can attach those event listeners, that can reinitialize the state and the functions that we need to actually handle user interactivity. That's what we call hydration. So you can see in single page apps, hydration is kind of really bad because we can render the whole page on the server, but then we need that the code for that entire page on the client for hydration. With multi-page apps, it's less of an impact because you only need to hydrate those small individual elements that you have made interactive, not your entire page. For everything else, initial load, navigation, these performance metrics are the highest possible thanks to streaming in both of these scenarios. But with multi-page apps, will give you a better JavaScript bundle size because, again, you're not building an entire app in JavaScript. You're doing a lot of work on the server. But that also means it won't have the best interactivity. Every time you navigate, it's going to be a full page reload. You're going to have trouble persisting client state across different pages. And of course, both approaches kind of lose on the composability and become really hard to work with if you want them to be the most performant that it can. So is this really the best that we can do? We want to build web apps that are performant, but we also don't want to make them a pain for us to work on. We don't want them to be a pain to scale, to reach a point of complexity. And I'm glad that the React team also thought that we can do better because they came up with server components. React server components are effectively a hybrid of both of these approaches. First of all, you'll see that we obviously have the initial load and navigation that we get through streaming, but we have the hydration and bundle size of an MPA and island setup because we don't do a lot of work, or we don't do all the same work on the client as a single page app. But we still have the interactivity of a single page app because we have client navigations and we have client state. And best of all, server components bring back composability by using compiler tricks. So what does this look like? So this example, I've built in Next.js because Remix doesn't support server components yet, but this is what it looks like. Let's go to this page. Let's refresh this. And it has the same streaming characteristic where we saw the loading skeletons, but all the data was started fetching on the server instead of on the client. So I can go to a different page. You'll see the same thing. I have the loading skeleton show up, and then we have the content. Server components, they look like normal React components, but the difference is that if I go to this featured product, you can see that I'm directly awaiting the server call in here, and I'm just using to fetch the data. So we using async await, we get back the co-location of data with our UI. So here we have the UI for featured data. If I go back right here, and I'm just making the call in the component. If I go to trending products, you'll see the same thing. I'm making that call and I'm rendering that data. We don't have any route loaders that are fetching data beforehand and then passing it through props or through context or something like that. We have the co-location that we really wanted, But we also have the nice benefits of hosting and streaming that we didn't have before. Same thing here in account orders. We can say that we have an account page here. So if I go to that page, you can see that I'm fetching that data directly in the component and then rendering it into HTML. This is really powerful from my perspective because we can go through this entire journey trying to optimize our single page apps by rendering them on the server, by hosting our data fetching, and doing things like that. But by moving to React Server Components, we get to retain all the co-location and composability benefits that we wanted, but still have really nice performance characteristics. Now, it still won't completely parallelize all the work as we had in the hosting in our hosting solutions, because we still have we could still have components that are further down the tree that are rendered at some later point, and then they have to fetch their own data. Or what I'm trying to say is that we still might have server waterfalls, but because the server is much closer to your data, those server waterfalls are a much smaller cost than client to server waterfalls. So that's my kind of, I guess, a 40-minute pitch for React Server Components. But the point of the talk was not that we should all move to React Server Components. It was that client server waterfalls are one of the biggest problems, or one of the biggest performance issues that we face while building single page apps. And there's a bunch of different ways to fix it. And we don't have to go all the way to server components. But hopefully throughout this talk, I was able to share some tricks or some tips that we can look out for when we are building our own apps. And we can keep a mental note of when we are running into these cascading waterfalls and how we can address those issues. I know for our projects, we are using Remix, at least at CareSource. So I would be happy to see that if some of these frameworks get adoption at other places, and what are the problems that they're solving for everyone. That is all I have. Thank you very much.
Anybody have any questions here for Dev? Just raise your hand and I'll stop over.
Yeah, I do.
All right. Just give him 1 second. All right, Derek, Mike.
Hi, Dev. That was an excellent presentation. I think everybody can agree.
Thank you.
When you were working with multiple async responses, have you looked into using something like RxJS to kind of manipulate and combine those async streams? And would that have any kind of impact on performance or make things easier to compose?
Sure. Yeah. So RxJS is a really nice solution to have to deal with like a lot of different async things. But it's still, so what RxJS would replace in the things that I showed would be like the await promise.all. So instead of using just regular promises to combine multiple async stuff into one, you would be using RxJS there. But you would still have the same problem of where exactly is that code located. If you put that code inside your component, you have the same issue even if you're using RxJS, because you still have to load the component, execute the component, and then you start your RxJS streams. Versus if you pull it up in a loader, you now don't have those waterfall issues, and you can combine all those streams into one. But that's still an extra manual step that you have to do, versus that being something that's automatically handled for you. So yeah, RxJS doesn't really solve the waterfall problem on its own, but there are a lot of other things that it does solve.
Awesome. Thank you.
Other questions for Dev? Dev, they want to see your cat.
My cat. Well, now she's no longer here. She lost interest. I'll post photos in the Slack. I have a bunch. She has an Instagram.
Any other questions for Dev here in the room? All right, Derek, anything online? All right. Dev, thank you so much for your time. We really appreciate it. Great presentation.
Thank you very much for having me. And if there is anything else, feel free to ping me in Slack. I can nerd out about web and performance and things like these forever.
All right. Thank you, everybody. Really appreciate it. Feel free to grab, there's desserts.